So, I've been doing a little bit of 3D printing, and in particular I've got a project to make a knife sharpener. It's like the Apex Edge Pro, which will be on the screen just here. And basically at the moment I'm making a piece that supports the block through which the main rail goes through. And this is basically a block that clamps around a 3mm piece of rod and creates a sort of bearing surface on which the other block goes on. And after doing a fair number of iterations, I realised that I might as well share this and show what process I've taken and how to design something in Blender in particular, how it goes on to be printed, and how we can have a little look at the print and see how it is. So this is the piece we're going to be creating. I've already made one obviously, but we're going to be making one slightly different with some slight changes, and you can see it slides on the rod and then you do it up and it stops sliding on the rod. It's very simple, but it's the sort of functional item and mechanical item that would be very useful to know how to print. So I'll just go over to the CAD and we can have a look at how it's done. Okay, so we're going to start off by adding our central geometry, which will just be a cylinder, and we will have 32 sides, 0.1 radius and 5 long. So this is just the 3mm rod that's running up through the centre of our part that you saw just earlier. And first things first, move it to the origin, and while I'm about it I'm going to move the cursor to the origin because otherwise it's going to be annoying me. And then we're just going to add the base part of the clamp itself, and this is going to be 1 radius, 2 length. So it's a 2x2 cylinder. It's a good size for printable things. So there we go, this is the base of the thing, and then we're going to add another cylinder. There's a lot of cylinders in this part, and this one is going to be just 1.5 long, and I'm going to rotate it along X by 90 degrees. I'm going to move it along X by 1 centimetre in the negative direction, and there we go, we have a secondary part. And what we're planning to do is we're planning to put a split down through here, and then we're going to clamp that closed onto this rod with a knob and a bolt, and I've got quite a clever scheme for being able to use a bolt in 3D printed part. So next what we need to do is we need to make the split, and that's fairly easy. What I'm going to do is add a cube. I want it to be about 0.2 maybe in that dimension. That looks about right, maybe 0.15. It's got to be about, well, we'll just leave it like that, and I'm just going to make that 3 long in the Z because we want it bigger. Okay, and then I'm going to take this face and I'm going to move it to 0. I'm going to take this face and I'm going to move it. It's more by eye. I want a fairly small area just here, so I'm going to make it 0.7. That looks about right. And I'm going to take this face again. I'm going to extrude it, and I'm going to extrude it all the way out here, and I'm going to scale, so I'm hitting S, and then I'm going to hit Y to choose the dimension, and I'm just going to widen that out until about there. You see we've got a nice wedge shape, and if I just hit 7, numpad 7, you'll see that maybe that's a little big, so I just scale Y again, and there we go. We've got a cut. So now we actually want to build this into some geometry. So we select our original cylinder, and let's just rename that. For clarity, let's rename it block, because I think it's going to be a block. And I'm going to go into modifiers, and I really like using Boolean modifiers for all of my 3D printing things. It allows me to adjust things later. I've just selected the curve there, so I actually want difference, sorry about that, difference, and you can see immediately it's got a nice cut out of it. And then I'm just going to add another modifier, and this one is going to be that cylinder, and I want it union, and that's in the wrong order, so I need to move that to the top, and then hide those other cylinders. Okay, and something is wrong. Scale 0.99, hide that, see if it works. It does. There we go. Right, back on track. Okay, add the boolean for the other operation. It's cube 001. We want to make that difference, and you can see it's coming together already. So we're just going to add another boolean modifier. This time it's going to be cylinder 10, and we want difference. And you can see it is already looking quite a lot like a clamp. And if you just imagine squeezing on these two parts, the part's going to flex inwards and do it. So next we need to model the bolt. Well, not the bolt, but the bolt hole, so we can see where we're going to have. So I'm just going to add another cylinder, lots of cylinders. Radius of this one will be 0.2, so it's a 4mm hole. Let's make it 3 long, just so that it's clearing everything. Just going to rotate it in X 90 degrees. We're going to set the X coordinate to be 1, -1, and you can see it's in the middle of that cylinder, so that's good. I am just going to get rid of it to see. Okay, so now what I usually tend to do at this point is we're getting a lot of parts in our layer, so I'm just going to make this parent. So these are parts that we sort of know are good, and they're really booleaning just this block, and if we were going to have another solid, we really want it to be separate. So it's good so far. What I need to do next is create a place for the nut to live just here. Now that's usually done with a 6-sided thing, and don't worry about the boolean sort of disappearing and appearing. If you have any problems with that, if you select the part that's got the booleans on it and hit tab twice, it takes you into mesh edit mode and back out of mesh edit mode, and that sort of resets the boolean, so that's a nice tip. So the radius will be 0.4 because the tip to tip distance on an M4 nut is 0.766 centimeters, and so we're going to round that up to 0.8 because we really want our nut to fit, and we're just going to make it one long. Okay, and now I'm going to move it away a bit just for now, and actually this will need to be at -1, and we can RX90, and I'm just going to I've turned into edit mode, so now I'm editing the mesh rather than the sort of objects, so I can move that with GY, and then it's 0.5 because it's a 1 centimeter long mesh, and that means now our coordinate reference is at one end. Now I'm just going to double tab on that to get back our mesh, and from here I'm going to hit 7 and hit Z, and that takes us into a wireframe mode, and then we can actually see the parts inside. So what I'm going to do is just put this, well, it has to be 3mm in, and that's about 2mm out, so it should be at about 0.4. That seems about right. So we need to have 3mm there because the nut is 3mm long. Okay, and then we need a relief in here because the knob is going to have to be bigger than this nut, so it has to have a bigger cylinder cut out of it than the nut. So add another cylinder, and this time go back to 32 sides. I like 32 sides, it's good. And I'm going to make that 15mm wide, that facing, because the 8mm nut will fit beautifully into it if I just move it to -1. Don't know why I set up. You can see sort of lots of space around it, and you don't want to be printing thin walls around your nuts, because when you give them a bit of pressure they'll just break. And okay, now I want to rotate this so it's horizontal, so RX90, you can see that that's now horizontal. This system is really annoying. So I want to have about 2mm of relief in there, so that'll be about -1. That's perfect for me. So that's sort of 2mm in there, or 2.5 in there. Okay, so now we just need to, you can see we've got a lot of Boolean modifiers. I just duplicated it twice. We want one of them that cylinder, and we want the other one to be cylinder 13. I'm going to just select that manually. Oh, deleted that, oh dear. And unfortunately, I believe that has got rid of 13 and 14. Interesting. So, just go back and manually select that. 14. There we go. Right, and I'm just going to hide those and switch back from mesh mode. And you can see that's where the nut goes. Beautiful, sitting in that piece of plastic. That's the mount for the thing. And actually, that looks a bit deep. That looks like it is going to leave, well, it's just bigger than it needs to be, isn't it? So I'm going to GY 0.1 minus, okay, and that means that we've got a thicker wall here. We always want as much sort of much thickness in our parts as possible because it's better for the printer and it'll make a stronger part. It means we can have a lower infill. So that's our clamp. It's a really simple part, and I'll show you later why I was definitely sticking to the booleans, why I like them. So next, another cylinder. We're going to make the little knob that allows you to adjust it. Okay, so this needs to be, I'm going to make it a mil smaller, and it's only going to be 0.5 long. We're going to move it out, RX90 it, refresh that, it's a real pain, and then we know where it needs to go. It needs to go at x minus 1, and I'm just going to go to the overview again and just move that there. And in fact, what I'm just going to do is GY 0.25 negative, and that means that our part, the center of our part, is right on that end. And if you're getting a complex part, it's always worth having the center on a face, unless you got it on the good reason for it. Okay, so let's make it minus 0.6. And I think what I'm just going to do is push that another 0.2, no, another 0.1. So that's 0.4 long now, so it's 4 mil long. Okay, and then we're just going to extrude 0.5, scale by 2, extrude 0.5, and you've got a nice big handle there. In fact, it's a little bit too big. I'm just going to select that loop, and we're going to scale 0.66, nope, 0.75, and that's a little bit more reasonable. No, maybe we'll make it big again. Scale 1.3. Okay, so that should be twice the size. So there we go. We have a handle. It looks like a handle. Next, I'm going to add some sort of gears on the outside, and that allows us to just have a better grip, because we want to be able to tighten this right down. So I'm going to duplicate that part, and then I'm going to invert that selection, delete all the faces, and we've just got a ring of faces around here. Right, now, every other face, there is a way of doing this, I'm sure, but it's actually really quick to just select. Ooh, there we go, right, and then I'm just going to delete all of those faces, because we only need every other face, and then I want to extrude individual, like this. Okay, now if we just turn on, see, actually we want that selection, select inverse, that should fill those in nicely. Okay, now we've got some problems with our UVs, our normal direction, so we're just going to recalculate those, and you can see everything turns white. Scale Y, because we want that bigger, And then what I'm going to do is I'm going to select all of these outer faces. So if I just hit C, we've got the paint selection tool, and hopefully I won't select too many of the main faces. So I just select that. I really screwed that one up. Okay, and then I just want to switch over to individual origins and scale Shift Y, because we don't want it to get bigger in the Y direction. And then we just widen it out, do it till it's basically touching, switch to median point, scale that out a bit, and then we go select similar by area, and then we just I think we want to scale those out a little bit. Okay, and maybe just scale them individually a little bit. Shift Y. There we go. Right, now, bit of Boolean magic time. Just going to Boolean that, select that, switch it to difference, and if I hide this, you suddenly got nice cogs. I'm just going to make that parent because it's a nice parent part. Okay. Now, we need to have a way of getting the bolt and the nut in there. So I'm just going to go to the nut, find okay, that part. Sorry about that. And just Shift D that on the Y-axis. Okay, scale Y -1, so that's just flipping the part. Okay, scale Y, make that a bit longer, 7, Z. Okay, now we want 2 millimeters of geometry just there, just to give it a bit of strength, so that's -0.8. And then we want to go copy that, give it that to Boolean against. Okay, and now we've got an interesting Boolean bug, and I bet if I go into union intersection, you see that's not at all what we want really. So we would put it back to difference, and then we go Control A, rotation and scale, and then it still doesn't work. So what do we do? Try, we'll just put it into section for a while. Okay, it's a mysterious bug. Now we want a cylinder. 32 sides will do again, and the radius, I'm just going to get one of my bolts and measure it, and we've got a 0.4 millimeter head, so I'm not going to do a 0.75 over 2, 0.35 radius, and the depth will be, say, 1, and then we're going to GZ minus 0.5, and then we're going to RX90, nope, hang on, RX90. We can see what our problem is there. That nut has somehow got all of its UVs reversed, so we're going to tab that. Okay, and now we can see that has gone back to doing what we thought it was going to do. So this is a good time to name our part handle, so we know that that's the one that matters, and then just go cylinder 18 again. What do we want to do? We want to set that at the minus 0.5, 0, 0. That should be -1 because that's the x-axis. It was the y-axis I was thinking of. We now RZ 180. So we just flip that round, and then if we go back to 7Z, we see, right, so now we want 3 millimeters in that nut, so that has to be minus 1.1 for the y coordinate. There we go. And this I am just going to scale in the Y a bit more. Control A, rotation and scale, copy this, and there we go. So hide those. And you have a more or less ready to print part. You can see, so what's going to happen is dropping a nut in there, and then we've got a pan-headed screw that screws into that nut, and then they lock together because nuts lock together when you screw them tight, and that means that you've got a screw basically locked into here. Now it could come out this way, out here, but it's not going to, because on the other side you've got a nut dropped into there and they're screwed in, and then as you do this handle up you should get this to closing. So to get this out into an STL, I just go File, Export, STL, and then that's the handle, Export STL, and I do the same for the block. Before you do that, probably worth doing a tab to make sure that the booleans are fine, but as you can see it's sort of all ready to go. We'll have to rotate this round in the slicer because we want this side down, even though it's got a little bit. Oh, hang on. Hold up. What we actually need is to find this. Completely forgot about that. Also, I completely forgot about adding some clearance, but that's not really necessary with the trick I'm going to tell you. So now what we need to do is Shift-D this, move it to the handle parent, and then I'm going to hide it, and then this, just duplicate that, get rid of that, and it is probably cylinder 18, I imagine. So if I hide whatever, nope, mysterious. Cylinder 15, nice. There we go. 15, get rid of that, hide that. You can see it now, it goes all the way through. That's a lot more sensible. Now, if we were not quite sure about our printer, we might make some of these holes a little bit bigger. I've already added some wiggle room in some of them, but particularly this hole and this hole might just benefit from being, you know, 0.05 mil, no, 0.5 mil bigger. Just to allow more clearance, but I'm pretty happy with the printer, so I'm just going to save this, export the STLs, and then we'll get to the slicer. Okay, so we've imported both of the models into the slicer, and as you can see they're really tiny. Got to scale them up by a 10 times factor because Blender, and then we're also going to add an extra 10% to the scaling factor, so that makes like 1100, because we're using white ABS, and ABS contracts about 10% when it cools, and we want our parts to be dimensionally correct. Then we've got to rotate the knob 90 degrees around the y-axis so it lies flat, so the big face lies flat. And so there they are. They need to be spaced apart a bit. And then 0.2 mil layer height, 20% rectilinear infill. We like rectilinear because it's much quieter. 6 mil brim to keep it stuck down. And those are the speeds and temperatures. So there we go. We've got a model ready to go. It just needs to be printed now, and here it is. Okay, so here's the parts printed, and I just ripped the brim off them. That's very easy. You can see it's got a bit of flashing still on there, so we might have to do something else. See the overhang there is a bit crap, but apart from that it looks good. There's a nice flex to the part. Maybe higher infill or more perimeters would be a good plan to make it stronger. You see a little gap in the perimeter there, but this part is mostly for gripping. It doesn't matter too strong. It's pretty, that's not going anywhere. So to assemble, all we have to do is we've got a 30mm M4 with a nut done all the way up to the top, and that means that they're sort of locked together. And if I was being really serious about this, I would get an Allen key and a spanner, and I would put those together permanently, well, more permanently. Then we just thread this in the top, we turn it around so it pops in. Then we can just shove that onto this side, the side with the big boss, and we should put the nut in there, spin that round, and as you turn it, it all tightens up. This bolt's too long, but I only have 30mm bolts and 15mm nuts, so until I've got this design really good, I'm going to stick to the long ones. So you just tighten it up, and it tightens closed, and there's really not much sort of spring resistance in this. So if you put it on a shaft, so this is a 3mm sort of ground shaft, these were ridiculously cheap on eBay, you can just screw it up nice and easy, finger tight, and it's not going anywhere. Like, I can't hold thing, and you just loosen it off again. Beautiful. Need to tidy up some of this flashing because it's sort of abrasive on the fingers, but apart from that, it's pretty much done.